Hello, I am Philippe Boyer, Lead Discovery Support Engineer. I have been working in BMC customer support for 15 years now. I am specialized in discovery issues, Helix discovery issues, as well as integration issues with discovery and other products. In general, my team resolves discovery issues, but today we will show you how to prevent issues from happening using administration best practices. This presentation is inspired by experience, by real issues reported by our customers. We will focus on the most frequent and the most impacting problem. I remind that this presentation is not about SaaS, ADE or Helix. In the SaaS cases, you do not have to worry about the administration of discovery because BMC will deploy it for you in our network and we will administrate it for you. In this webinar, we are going to present an overview of discovery. We are going to present an overview of the goal of the discovery administration. We will review the typical health issues and the best practices to keep them from happening, that is, monitor, backup, and compact. Very quickly, discovery allows you to know your IT well enough to manage it. It can scan your IP ranges with your credentials. It models your hardware and software. It models the relations between them, and it allows you to use this information to model your own impact and service models. The discovery scan results are required to implement ITIL, including impact management with AEOps, event management with BHOM and TrueSight, asset management, change management, incident and problem management with ITSM. The goal of discovery administration is to discover and share what you want, when you want, as fast as you want, and as frequently as you want. The typical health issues are disk full, performance issue, and data store corruption. This presentation will tell you how to minimize the probability of this issue, detect them earlier, and take actions before they keep you from reaching your goals. Let me show you what are the links between these different issues with this impact diagram. It is available in our knowledge base article. You can find it if you search for the keyword Discovery Impact Diagram in bmc.com/support. The black boxes are root causes, the blue boxes are intermediate symptoms, and the red boxes are final symptoms, the exit points of the impact graph. This diagram shows that the typical health issues are systemic and interconnected. For example, a performance issue can cause a disk full can cause a data store corruption, a data store corruption can cause another disk full later, and if a cluster member goes down because of that, it can cause a performance issue and a disk full in another member. Because health issues are systemic, a systemic approach is needed to prevent them from happening. Administration best practice. We have collected the feedback from all the discovery support engineers. We asked them according to their experience what was the most pertinent things to do to prevent health issues from happening. Their answer is very simple. If you want to be successful in your discovery, administration, and maintenance, if you want to prevent the most impacting issues from happening, if you want to mitigate their impact and resolve them faster with less effort, the three most pertinent things to do is to monitor, backup, and compact. Administration best practice, monitor. Monitoring will allow you to anticipate issues and take actions to prevent them from happening. The best to monitor the health and performance is to check the support archives. That's the auto-diagnostic tool embedded in Discovery. I will show you how to run it and review the results in this webinar. Monitoring the free disk space is of course recommended. The recent version of Discovery are configured by default to raise alerts in the UI when the disk usage is unreasonably high. What you have to monitor is these alerts. Monitoring the DDD removal is recommended. This not deletion activity is tightly linked to the health of Discovery. I will show you how to check that in this webinar. Let's see the next best practice, backup discovery. taking backups is recommended even if you have a discovery cluster, even if fault tolerance is enabled. Of course, this won't keep issues from happening, but by experience, there is nothing more pertinent to do to resolve issues faster, mitigate their impact, avoid losing time, data, and money. We have seen how important it is to monitor discovery and take backups. Let's see the next best practice: compact the data store. Compacting the data store once a quarter at least will help you to keep the data store size under control. This is a simple maintenance operation. We did our best to document that it has to be done, but by experience it is frequently omitted or delayed. Now let's do a monitoring demo. We are going to check the health, check the disk usage of a cluster, and check the DDD removal together to show you how to monitor discovery, how to monitor the health. This is my discovery. Let's go to Administration. And we are going to run the health check that is embedded into the product. To do that, go to Appliance Support, click on Create, select a name, and at the bottom of the screen, check Support Archive and Create. This is going to execute the health check tool of discovery on the coordinator. It is going to analyze the logs, looks for interesting error messages, provide reports about performance, analyze the different versions of the different patterns, and look for inconsistencies in the configuration of discovery. This is finished now. It typically takes some minutes to execute. Now we are going to open the file. I click on Health Check, the name that I have specified in the previous screen. And here is the file. If you open it, you will find in TMP one TGZ file per member. So one of them is bigger than the other one. That's the coordinator. That's the one where the health check tool has been executed. Let's open that. And in TMP, you will have this file. That's the one that contains all the reports about the health check tool. Let's open that. In TMP, you have different files. The most important one for this presentation is twsupporttool.latest. We are not going to review the other files. They are mainly used for investigation purposes, but this one will help you to evaluate the health of discovery. Let's open that. At the top of the screen, you will see the results of the health check checkpoint. They are sorted by order of severity. There are something like between 200 and 300 checkpoints that are implemented. They are not always executed because they are not always pertinent. For example, some of them are specifically about the multi-generational data store or specific to the cluster configuration. So they are not always executed. The checkpoints cover different aspects of the health: the configuration of discovery, the hardware configuration, the versions, the performance, the different errors, and the different data inconsistencies that could be detected with this tool. Let's review the first lines. The most important one in this case is that the latest compact is older than 6 months. So that's typically the kind of thing that can lead to a health issue, a disk full, and a performance issue. In the line number 3, you have, with the severity 6, an error saying that the version of the TKU and the ServiceNow sync patterns do not match. This suggests that there is something inconsistent in the configuration. In the line number 4, you can see an error saying that there are some RPMs detected in the appliance that are not mentioned in the documentation of the latest OSU. So it suggests that this could be a possible OS customization, and this presents a risk of failure during the next upgrade. In the line number 5, you have an error that suggests that there are some files that should not be there. So this kind of errors can help to evaluate the health of discovery. I'm going to show you another report. This time there are more errors at the top of the screen. Some of them have the severity 9. For example, the one at the top says that the size of the DB partition is not compliant with the documented recommendations. If you check the next line, you see that there are very frequent communication errors between members. The next one is again about the CPU configuration that is not compliant with the documented recommendation. If I'm looking for other types of checkpoints, this one will be about the version of the OSU. This one is older than 6 months. After the line number 10, there are some checkpoints that are reported as failed. However, the severity is pretty low. What I recommend is to focus on the top of the list to detect what are the most important failed checkpoints. Each of the checkpoints are documented in our knowledge base. I'm going to show you the article. To find it, search for discovery, health check, focus on discovery, and at the top of the list you have how to check the health, auto diagnostics. We are going to open that. In this article, most of the checkpoints are documented with the procedure to execute the health check, what we have just done, a sample, and a recommendation and an explanation for each of the checkpoints. For example, the biggest dupe file is bigger than this particular size. If you have an error like that, then here it tells you what it means, what you have to do. I recommend administrators to focus on the checkpoints at the top of the screen because they are a synthesis of the rest of the report below. The rest is much more detailed. It is typically used by BMC customer support to investigate issues. Note also that a checkpoint is only a checkpoint. It can help to diagnose issues faster, but it can't replace an investigation. For example, if the logs were deleted or if VMware snapshots were used to backup discovery, a checkpoint will report that there are no traces of backup in the logs. This doesn't necessarily mean that discovery was not backed up. Also, it would be exaggerated to consider each failed checkpoint as a failure that requires an urgent investigation. The role of a checkpoint is to evaluate faster the health of discovery, and my best recommendation when you find a checkpoint is to have a look to the knowledge base article to check what it means. And then, if you think you need assistance, do not hesitate to open a support ticket. I'm going to show you now how to monitor the performance. The performance is a pertinent indicator of the health. If one day discovery is not healthy, you will probably observe a change in the performance. It is certainly going to decrease. So the performance indicators are monitored every hours when you run the support archive. It's not in this file, it is in this file, hourly statistics. I'm going to show you how to open this CSV file with Excel and then turn the statistics into a wave. That's the statistics. I'm going to show you how to display the number of IPs that were scanned, hours per hours. To do that, select the two first columns, go to Data, go to Insert, create a wave, and Excel does not directly understand the time format of the CSV file. So with Excel, to change that, you have to click on Format, Chart Area, Chart Option, change the axis option. In the axis options, you have to select Text axis. In this example, there is a peak at the beginning of the scan. This is because at the beginning of the scan, a lot of IPs will finish. This is because they are not responding, for example, or there's no valid credential for them. So for this reason, at the beginning of the scan, there will be a peak. This is normal. What you may observe if one day you do not compact frequently enough is a performance that decreases days after day. I am going to show you now how to check if the data store is corrupted or not. To do that, open an SSH session on one member and then execute the command tw_support tool, check DB corruption, restart services. This command is going to stop the services because to check the DB corruption, you have to stop them. When the tool has finished to execute some of the checkpoints, it asks for a confirmation if you really want to stop the services. In this case, press yes. And now it starts to verify the data store. The duration of this process typically takes some hours. We recommend in general to wait for a night to let the tool run. The DB verification is now finished and the tool is restarting the services. As you have understood, checking if the data store is corrupted implies that you will stop the services and they will stay down for a few hours. It is not recommended to do that very frequently, of course. Normally, we check if there are DB corruption, mainly in the case of core dumps caused by the process running the data store. We call it the model service. However, it could also make sense to check if the data store is corrupted just before you take a backup. This way, you are sure that the backup you take is valid and it's not going to cause any issues if you restore it. The verification is finished now. The tool is finishing the last checkpoints and it is going to generate the report in the TMP folder of the member. The tool is finished now. As you see, the report has been dumped in the folder TMP. Let's have a look. Here is the file. I'm going to open it. I'm going to open the file twsupport.latest. Search for the keyword corruption. And this section will tell you that DB verify did not detect any corruption. Of course, in case of DB corruption, the tool is going to raise an alert at the top of the file. This way, you don't have to review the rest of the report. This procedure is documented in our knowledge base. Search for the keyword discovery, how to check if the data store is corrupted. And here is the article that tells you how to check if the data store is corrupted. Note that in the case of a cluster, this procedure has to be executed on all the members. I am going to show you now how to monitor the disk space. Here is the error message that you will see in the UI if one day the disk usage of one of the members is unreasonable. To tune the settings of discovery to report these alerts and take actions, you have to go to Visit Baseline for detail. At the bottom of the page, you have a button that is Configure Disk Monitoring Options. So there is 3 thresholds at 30% by default, 20 and 10. As you see, there is an action that is taken. At 30%, you have a warning. At 20%, you have a warning and discovery would stop. And if there is only 10% of remaining disk space, then discovery will go down. To check the disk consumption of the whole cluster, you can go to Administration and then Cluster Management. And in this page, you will see the disk consumption of all the members for some of the partitions. In this case, this particular member is the one that has an issue, and the typical root cause for this kind of problems can be, for example, a core dump or an unreasonable accumulation of fragmentation. It can be also an unreasonable accumulation of nodes to delete. And if you are facing a problem like that, search for discovery disk full. And near the top, you will find an article that talks about all the known root causes that can cause this issue and what to do. Let me show you now how to monitor the DDD removal. To do that, you have to go to Administration and then Performance and then DDD removal. So the DDD removal is an activity of discovery where discovery deletes the nodes that are not useful anymore. What is important is to have the red line and the orange line that are now at the bottom of the screen. They must stay at 0 or converge towards 0. If they diverge and then they increase all the time, this means that discovery doesn't have enough time, enough resources to delete what it has to delete. I'm going to show you an example where the DDD removal was not working correctly. Here is an example where the DDD removal is not working correctly. Here, the red line, that's the DAs eligible for removal. The DAs are discovery accesses, a particular kind of nodes that are created each time discovery scans an IP. As you see, there is an accumulation and there are more and more nodes. So this typically means that the DDD removal is not working correctly, it's blocked, or it's not fast enough. It can be also the consequence of a performance problem. A performance problem that can be caused by a lack of compaction, for example. In the example below, you have another example where this is the orange wave that for a moment could not converge to 0, and then this metric started to increase. The orange wave is representing the number of DAs pending removal. This means that discovery detected that they were eligible, it took actions to delete them, and now the DAs are pending for removal. The way the DDD removal works is also reported in the support archive at the beginning of the file. In this example, you have a checkpoint that is failing because there are more than 1% of the DAs that are older than the DDD removal. The severity is low because the percentage is low. If this number was something like 20 or 50%, then the severity will be higher. The support archive allows you to receive an alert if it's too high, but the DDD removal statistic in the UI of discovery allows you to detect trends. For example, if there is something that is not converging towards 0, it's easier to see it, while the alert will only tell you that a particular threshold was reached. Here is a summary of this presentation. The most important issues are disk full, performance issues, and data store corruption. The main discovery administration best practices are monitor, backup, and compact. We have seen that the most pertinent things to monitor are the health check, the disk usage, the DDD removal, and if possible, the DB corruptions before taking a backup. We have seen that your backup plan should be tested and automated, even if your cluster is fault tolerant. We have seen that the compaction has to be done at least once a quarter. This webinar will be published on YouTube with the references mentioned in this slide. And that's the end of my presentation. Thank you so much.